Good evening, welcome to Sakala Vidya YouTube channel. So in the last class we have discussed up to third problem. So now we shall discuss the fourth problem. Right. So let me discuss the fourth problem. Fourth one. F of x equals to x upon 2 if x less than 2, x square upon 3 if x greater than or equal to 2. A is equal to 2. That means at x is equal to 2 we need to verify the limit. So that means actually here what we need to do, so we need to find out left hand limit and right hand limit. If left hand limit is equal to right hand limit, then we say that limit exists at x is equal to 2. So let us verify now. So now the solution, first here LHL let us find out. LHL means limit x tends to 2 minus f of x. So that means x tends to 2 minus means x less than 2. So x less than 2 means the function is x upon 2. So good evening Pavitra, good evening Siva, Ishwar, Karthik. So now limit x tends to 2, instead of f of x we can substitute x upon 2, right, x for 2, 2 upon 2 is 1, left hand limit is 1. So now let us evaluate right hand limit. So right hand limit is equal to limit x tends to 2 plus, that means good evening, x tends to 2 plus means x greater than 2. X greater than 2 means the function we need to take as defined as x square by 3. So now this is f of x. We can write like this, limit x tends to 2. Now we can define the function as x square upon 3. So this is equal to 2 square upon 3. That will be 4 by 3. Now what do you observe? What do you observe? Yes, you are correct. Now we observe that LHL does not equal to RHL. Hence, limit x tends to 2, f of x does not exist. So this conclusion need to be given. Lavanya, welcome. So next question is fifth one. First note down the fifth question. F of x is defined as, it's a piecewise function. It is defined as x square if x less than 1. 2x minus 1 if x greater than or equal to 1. Now we need to verify the limit at 1, at a is equal to 1. Yes, limit does not exist, absolutely correct. Okay, now Pavan. Okay, good evening. So this is the problem now. Okay, let us do it now. Now the solution. First, let us evaluate left hand limit. That is, limit extends to 1 minus f of x. So we know that as x approaches to 1 minus from left hand side means that x is less than 1. When x is less than 1, the function we need to take x square. So this we can write limit extends to 1. Instead of f of x, replace x square. Now substitute the limit, that will be 1 square. Obviously you get 1. Am I correct now? Durga Prasad. Now right hand limit. Limit extends to 1 plus f of x. See, extends to 1 plus means x is greater than 1. Then the function is actually we need to take like this, 2x minus 1. So now the limit extends to 1, 2x minus 1. Now the value of 2x minus 1 at x is equal to 1 we need to find out. 2 into 1 minus 1. 2 minus 1 is equal to 1. Now what do you observe? LHL is equal to RHL. Therefore, LHL equal to RHL. Therefore, limit extends to 1, f of x equals to, we can say 1. Thank you, Karthik. Thank you. Next, let us move to the fourth question now. Fourth problem. If f of x equals to, please note down the question first, all of you. F of x equals to 2x plus 3 if x less than or equal to 0. 3 times of x plus 1 if x greater than 0. Find limit extends to 0 f of x and limit extends to 1 f of x. Both the limits we need to find out. Okay, let us find out now here. Right. Now solution. First, to find limit extends to 0 f of x. First let us find out this one. Right. LHL, limit extends to 0 minus f of x. So that means since x tends to 0 minus means x less than 0. When x less than 0, the function we need to take 2x plus 3. So limit extends to 0, 2x plus 3. Now what do we get? 2 times 0 plus 3. 0 plus 3 equals to 3. This is LHL only, left hand limit. Okay, very good, Karthik. Good try. Now RHL, limit extends to 0 plus f of x. So now extends to 0 plus means x is greater than 0. X is greater than 0. So when x greater than 0, limit extends to 0. Now the function, you check it now, 3 times of x plus 1. 3 times of x plus 1. Substitute the limit. So we get 3 times 0 plus 1. This is 3 into 1, 3. So that means left hand limit is 3. And next right hand limit also 3. LHL equal to RHL. Therefore, each equal to 3. So hence, limit extends to 0, f of x equal to 3. We conclude that this value is 3. Now let us proceed for limit extends to 1. Limit extends to 1. Next, to find limit extends to 1. So here for example LHL means left hand limit means extends to 1 minus, that is x less than 1. So we don't have x less than 1, x less than 1 in this one. In this case only x greater than 0 we have. So that means it is not included in the domain. So LHL we should not find out. We check RHL. RHL means extends to 1 plus. That means, that implies x is greater than 1. Yes, it is there. So that means now in this case only RHL we need to find out, not LHL. LHL, there won't be any LHL arises in the case of this limit. Only RHL is the value. So that means now the solution here, limit extends to 1, f of x is same as limit extends to 1 plus f of x. That means only right hand limit. So here limit extends to 1, you can write 3 times of x plus 1. It's a very interesting problem. 3 times 1 plus 1. So 3 into 2 equal to 6. This is the answer. Yes. Now the fifth problem. Fifth problem. Show that first problem, in that limit extends to 2 minus mod of x minus 2 upon x minus 2 equal to minus 1. This is very important problem. So why should we LHL we should not consider, means x less than 1 is not there domain, only x greater than 1. That's why LHL is not at all actually considered in this case. Directly the limit is equal to RHL only. Okay, now the solution. So this is the actually left hand limit you need to find out, LHL only. That is limit extends to 2 minus modulus of x minus 2 by x minus 2. So now interesting concept need to be discussed here. X tends to 2 minus means x less than 2. Bring to this side. That means x minus 2 is less than 0. If x minus 2 is less than 0, the mod of x minus 2 is defined as minus of x minus 2. Please remember like this. So now the problem becomes limit x tends to 2. Now remove this sign, no problem. This will be minus of x minus 2 upon x minus 2. Both numerator and denominator only same, but their signs are different. X minus 2 1 ja x minus 2. So limit x tends to minus 1. So minus 1. That's our answer. Right. Next, in this only we have the second bit. Second bit we need to discuss under 5. Limit x tends to 2 plus x minus 2 upon mod of x minus 2 equals to 1. We need to prove. So that means only here right hand limit we need to find out. Solution. Okay. Limit x tends to 2 plus x minus 2 by mod of x minus 2. This is left hand side. LHS, not LHL. Left hand side is equal to right hand side, you need to prove. Here x tends to 2 plus means x is greater than 2. That implies x minus 2 is greater than 0. As x minus 2 is greater than 0, the modulus of x minus 2 is defined as x minus 2 only. Yes. So this is equal to limit x tends to 2 x minus 2 upon x minus 2. X minus 2 1 ja. So this will be 1. This is RHS. Hence proved. Now let us move to the sixth problem. So let's have a discussion on the sixth problem. Very good, Karthik. Show that limit x tends to 0 plus 2 mod x upon x plus x plus 1 equal to 3. So this is the problem. So welcome, Karthik. Thank you, Durga Prasad. Okay, solution now. Consider left hand side equals to limit x tends to 0 plus 2 mod x upon x plus 1. Here x tends to 0 plus means x is greater than 0. When x greater than 0, the modulus function is defined as plus x. So now we can write limit x tends to 0. Instead of mod x to x, x you can write 2 times x to x upon x plus 1. X gets cancelled. We have limit x tends to 0. 2 plus 1 is 3, x plus 3. Let us substitute the limit now. 0 plus 3 equals to 3. What we need to prove? Yes, 3. This equal to RHS. Hence, prove. So let us move to the seventh problem. Seventh problem. Let f of x equals to integral part of x, greatest integer function, plus x. X belongs to real number system. Compute means you need to calculate. Compute first one, limit x tends to 2 plus f of x. Second, we need to find out limit x tends to 2 minus f of x. Hence, check whether f of x has a limit at x is equal to 2. So just all of you read the question. Look at the screen first of all. Go through the question. Okay. Now the solution. Here given f of x is equal to integral part of x plus x. Domain is x belongs to total real number system R. So that means first we need to find out left hand limit. LHL. Limit x tends to 2 minus f of x. So that means when x tends to 2 minus means here particularly whenever integral part is concerned means this will be 1 less than or equal to x, x less than or equal to 2. This is the meaning whenever integral part is concerned. Then therefore the integral part of x is becomes 1. When just x less than 2, integral part is equal to 1 we need to consider. Because x is equal to 1, if you substitute 1 you get 1 itself only. So that's why you can write limit x tends to 2. This is integral part of x plus x. This is 2 minus. Whenever 2 minus, the integral part of x becomes 1. So this is limit x tends to 2. This integral part of x is replaced by 1 plus x. Substitute the limit. 1 plus 2 is equal to 3. That means left hand limit is equal to 3. Now let us find out right hand limit now. Right hand limit. RHL. This is the first problem actually. Limit x tends to 2 plus f of x. Here interesting factor is that x tends to 2 plus means here we need to consider 2 in between 2 to 3. 2 less than or equal to x, x less than or equal to 3. Therefore, integral part of x becomes 2. Integral part of x becomes 2. So now the limit x tends to 2 plus integral part of x plus x. Now the integral part of x is replaced by 2. Go to Venkat Reddy. So limit x tends to 2. This is 2 plus x. 2 plus x is the polynomial function. Directly we can substitute the limit. 2 plus 2 is equal to 4. So right hand limit, left hand limit are not same. So LHL is not equal to RHL. Hence limit x tends to 2, f of x does not exist. Does not exist. Mahesh Peddapati. Good evening, good evening, good evening. Gopu Venkat Reddy, good evening. Now, eighth problem. Eighth problem. This is limit chapter. Singirala Anand. Compute limit x tends to 2 minus square root of 2 minus x. What is limit x tends to 2 root of 2 minus x? That we need to find out. Right now, first of all, we need to find out domain of this function. See, for a domain of, say, this f of x is equal to 2 minus x, root of 2 minus x. 2 minus x must be greater than or equal to 0. Multiply with minus 1, you get x minus 2 is less than or equal to 0. X less than or equal to 2. So that means its domain of this function is equal to, you can write minus infinity to 2 closed. That means only less than 2 means left hand side limit will exist. Right hand limit will not exist for this one. So that means left hand limit itself is the limit of this function. That we need to find out. So now first compute the left hand limit now. Solution. This LHL equal to limit x tends to 2 minus root of 2 minus x. So now this equal to limit x tends to 2 only, same root of 2 minus x only. Substitute the limit. root of 2 minus 2, that will be root 0 is 0. As the domain is x less than or equal to 2, therefore the value of this limit is equal to, therefore limit x tends to 2, root of 2 minus x equal to limit x tends to 2 minus root of 2 minus x, that value equal to 0. So answer is 0. Yes. So ninth question. Ninth one. Find the following limits. Find the following limits. First one, limit x tends to 0, x to the power of 3 by 2. X to the power of 3 by 2. So 1 minute, I will continue. So 1 minute, let me continue. So now the solution. Limit x tends to 0, x to the power of 3 by 2. See, we need to discuss the domain of this function. Let us say here f of x equals to x to the power of 3 by 2. This we can write x cube root of x cube, we can write it. So that means the domain of this function is x must be greater than or equal to 0. That means only right hand limit will exist for this one. So that means this directly we can substitute x greater than 0 or equal to 0 only, the limit of the function we can find out. So that's why this is equal to 0 to the power of 3 by 2. Substitute, you get answer 0. Limit is 0. That's also obviously it will be right hand limit only, not left hand limit. Second question. Second question. Limit x tends to 0, root x plus x to the power of 5 by 2. Okay, solution. Limit x tends to 0, root x plus x to the power of 5 by 2. So that means the domain is equal to domain of this function. Domain of this function is x greater than or equal to 0 only. Because root x, even root x to the power of whole 5 also, x greater than or equal to 0. So that means no LHL for this one, directly RHL. So substitute the value. Now root 0 plus 0 to the power of 5 by 2. So this is 0 plus 0 equal to 0. So next, let us move to the next problem. So today's last problem. Tomorrow we shall discuss, this exercise has been completed. So now left hand limit, right hand limit problems and limit of the function values completed. So tomorrow we discuss theorems on standard limits. Okay. Now 10th question. Suppose f of x equals to is defined as like this: a plus bx if x less than 1, for if x is equal to 1, b minus ax if x greater than 1. Next, if limit extends to 1, f of x equals to f of 1. Find the possible values of a and b. Right. So that means limit extends to 1, f of x is f of 1 means here 4. That means limit exists means right hand limit will exist, left hand limit also exist, because here x less than 1 is there, x greater than 1 is there. Understood now? F of 1 means f of 1 is equal to 4 is given. So that means we need to find out left hand limit and equate it to 4. So we need to find out right hand limit and equate it to 4. We get two equations in a comma b. So now we need to solve. This is the plan. So let us apply our plan now. Solution. So given, what is given here? Function is given. F of x equals to, am I audible? Am I audible to you? Clear? A plus bx if x less than 1, for if x equals to 1, b minus ax if x greater than 1. So we have LHL is also equal to f of 1. That implies limit extends to 1 minus f of x equal to, this is 4. So that means when x less than 1, the function is limit extends to 1, we can write. So a plus bx equal to 4. Substitute the limit, a plus b equals to 4. Say equation 1. Karthik, absolutely correct. Pavitra. So now we have RHL equal to, that is also f of 1. So now let us write RHL. Limit extends to, what we need to write? 1 plus f of x equal to, f of 1 is defined as 4. So this is 4. You check. So now limit extends to 1. X greater than 1, that is b minus ax. So that is 4. Substituting limit, b minus a equals to 4. Say equation 2. Now solving 1 and 2. What is the first equation? A plus b equals to 4. Second equation is what? Second equation, b minus a equals to 4. So minus a plus b equals to 4. First adding, say this is 1, this is 2. Adding A gets cancelled. 2b equals to 8. Now b equals to 8 upon 2. So you get 4. Now substituting b is equal to 4 in equation 1. So we get a plus b. B means 4 equals to 4. A equals to 4 minus 4. So 0. So hence possible values for a comma b are a is equal to 0 and b is equal to 4. This answer. So after completion of this I will start differentiation. Don't worry, but we need to discuss even okay, one by one check the answers now. This is the question. Second equation. This is the answer. Okay, thank you. See you. Have a nice day.